Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Asna SYAHIRAH binti Haji Amir SAIDON. I am final year student from KOLEJ KEMAHIRAN TINGGI Ledang in Biomedical Electronic Engineering Therapeutic.
Hi, I am AISHAH binti KHAIRUDDIN. I am final year student at KOLEJ KEMAHIRAN TINGGI Ledang in Biomedical Electronic Engineering Therapeutic.
Development of negative pressure wound therapy using Arduino. This is a device that used to patient who has wound such as injury, burn or diabetic to reduce their wound. So this is table of content. First, introduction. In introduction, we will explain about project background, problem statement, objective and scope. Next, literary review. In literary review, we will explain about comparison between our project and past project. Third, material and method. In material and method, we can explain about component, block diagram, circuit diagram and flowchart. Last but not least, demonstration project. In demonstration project, we will show you about our project and data analysis. Next is project background. Some patients with open wound require special care in order to heal effectively and avoid any complication. This is due to lack of skin covering to wound area, which the skin is the first layer of defense against microorganisms such as bacteria. As for diabetic patients, their wound may take longer time to recover as the condition of patient body itself prevent the wound to heal as a healthy person do. With that condition in mind, negative pressure wound therapy is being developed. The function of negative pressure wound therapy is to enhance wound healing, especially on diabetes patients. Furthermore, this project is designed in portable design, which is patient can easily use it at home and no need to go to hospital. For the problem statement, first, wound on diabetic patient taking longer time to heal. Next, diabetic patient need a special care or treatment to ensure proper wound healing. Third, treatment is too expensive for diabetic patient as it requires special care and longer time. Objective for the project is first, to develop negative pressure wound therapy. Second, to control pressure for negative pressure wound therapy. Third, to analyze the suction rate for negative pressure wound therapy. For the scope, we use DC current as a supply to maintain negative pressure wound therapy. Second, to develop portable device to carry around the environment. Third, suitable to treat wound with not longer than 3 multiple 3. So this is the comparison between past project and our project. So this is the past project. First, wound vac. Wound vac use foam and gauze dressing. The pressure that device apply is negative 15 to negative 200 mmHg. Operation mode is continuous. The bandage change 24 hours to 74 hours. This device suitable use for burn and injured. Next is VAC Freedom. VAC Freedom use granule foam and 300 ml canister gel. The pressure that device use is negative 15 to negative 200 mmHg. Operation mode is continuous and intermittent. And this device can use depend on severity wound. Last, Siemens NPWT. The Siemens is use NPWT suction pad silicone drain. Maximum this device can supply is negative 200 mmHg, but this device recommend to use around negative 14 and negative 18 mmHg. Operation mode is continuous, and this device suitable for wound diabetic. So this is our project, negative pressure wound therapy using Arduino Uno. This project use bandage. The maximum pressure that this device can provide is negative 300 mmHg. Recommended use below than negative 100 mmHg. The bandage is single use. This project used for wound diabetic patient and some injured based on severity. This project has 3 options. 3 option wound size. First 1 cm, second 5 cm and third 8 cm.
So this is list of material hardware and software for our project negative pressure wound therapy device using 1. Vacuum pump. A vacuum 12 volt is used to provide current and voltage to the pressure negative that will give 20 watt for support our project. 2. Meter gauge. Gauge meter to obtain a manual output reading when the pressure is within a maintenance range in kPa and PSI. 3. Arduino Uno. As a microcontroller to connect additional hardware as LCD and push button in programming and send the data progress. 4. LCD to display output from programming, from counter timer and gauge pressure. 5. HX710 to maintain the pressure for the range of negative pressure that from 25 to 14 kPa with vacuum pump process. This component can support 3.3 to 5 volt. So this is a block diagram for our project negative pressure wound therapy to show the input and output of our project. The input of our project is a pressure sensor HX710, which for a Kktm negative pressure set in the equation formula and given to the patient. The output of our project is a main component in our device, which is a vacuum pump that connects from the Arduino Uno, a motor driver as well as a pressure sensor for the pressure given to patient negative suction. Then the LCD will display the range pressure with a counter timer. During process, gauge meter will manual vibration and at the same time that will suction the patient when using a bandage. So this is our circuit diagram that shows the connection or hardware for connection between get input, microcontroller and output. Then this is project our project command flow from Arduino IDE to hardware function. First part is command to send the flow to the selection button to press from the selection option of treatment. Then give 3 option treatment, which mean size 1 cm with 3 mini, medium size 5 cm with 50 mini, and large size 8 cm with 30 mini. Last command is the receive on the selection treatment to the start the process vacuum pump. In the same process, timer will counter follow the pressure that such negative range pressure from negative 20 kPa to 40 kPa. After treatment finish of success, instruction will return back to main menu to start again the treatment.
First, plug the device adapter and switch on. Install a bandage according to the size of the wound patient on the suction scalp. Attach a bandage to wound on the patient's skin. Press the button option to select the treatment. Press the button Start Stop.
For the last part, analyze this data during the demonstration. 5 different reading at the each minute and size that calculate all the data output